This session, here we focus on the main primary questions in the concrete technology. Out of that questionnaire, first 10 questions, here we focus on that. The questions are: what is concrete, water quality standards, what is influence of the tri and dicalcium silicate and tricalcium aluminate on the properties of cement, then what is hydration, on which factors the rate of hydration depends, next appropriate composition limit of Portland cement, what are the main stages in the manufacturing of Portland cement, and short note on blended cement and Portland blast furnace cement. What is meant by surface texture of aggregate, sieve analysis, and final question is physical properties of aggregates. First question is, what is concrete? Concrete, in the broadest sense, is any product or mass made by the use of a cementing medium. Generally, this medium is the product of reaction between hydraulic cement and water. But these days, even a definition would cover a wide range of product. Concrete is made with several types of cement and also containing pozzolana, fly ash, blast furnace slag, microsilica, additives, recycled concrete aggregate, admixtures, polymers, fibers. These concrete can be heated, steam cured, autoclave, vacuum treated, hydraulically pressured, shock vibrated, extruded, and spreaded. This immediately begs the questions: what is the relation between the constituents of these mixtures? There are three possibilities. First one can view the cementing medium, that is the products of hydration of cement, as the essential building material, with the aggregate fulfilling the role of a cheap or cheaper diluent. Second one can view the coarse aggregate as a sort of mini masonry which is joined together by mortar, that is by a mixture of hydrated cement and fine aggregate. The third possibility is to recognize that the first appropriation, concrete, consists of two phases: hydrated cement phase and aggregated, and as a result the properties of concrete are governed by the properties of two phases and also by the presence of interfaces between them. The second and third view each have some merit and can be used to explain the behavior of concrete. The first view, that of cement paste diluted by aggregate, we should dispose of. Suppose you could buy cement more cheaply than aggregate, 10 times larger than shrinkage of concrete was 250 kg of cement per cubic meter. The same of concrete applies to creep. The heat generated by a large amount of hydration cement, especially in a hot climate, may lead to cracking. So good concrete, in the good concrete Beneficial means that the influence is good, and indeed we should ask good concrete a substance with the consistence of soap hardened into a homogeny or the honeycomb non-homogeneous and weak mass. This material is made simply by mixing cement, aggregate and water. Surprisingly, the ingredients of good concrete are exactly the same, and the difference is due entirely to know-how. With this know-how, we can make good concrete, and there are two overall criteria by which it can be defined. It has to be satisfactory in its hardened state and also in its fresh state, which being transported from the mixer and placed in the framework. Very generally, the requirements in the fresh state are that the consistency of the mix is such that the concrete can be compacted by the means which are actually available on the job, and also that the mix is cohesive enough to be transported and placed without segregation. These requirements are not absolute but depends on whether transport is by a skip with a bottom discharge or by a flat tray lorry. The latter of course not being a very good practice. As far as the hardened state is considered, the usual requirement is a satisfactory compressive strength. We invariably specify strength because it is easy to measure, although the number that comes out of the test is certainly not a measure of the intrinsic strength or concrete in the structure but only of its quality. The strength is an easy way of ascertaining compliance with the specification and sort out contractual obligations. However, there are also other reasons for the preoccupation with the compressive strength. These are density, impermeability, durability, resistance to abrasion, resistance to impact, tensile strength, resistance to sulfate, and some others, but not shrinkage and not necessarily creep. We are not saying that these properties are a single or unique function of compressive strength, and we are aware of the issues of weather durability. The word concrete is derived from the Latin concretus, meaning to grow together. Concrete is a composite material composed of coarse granular material, the aggregate or filler, embedded in a hard matrix of material, that is the cement or binder, that fills the space among the aggregate particle and glues them together. The simplest definition of concrete can be written as a concrete is equal to filler plus binder. Depending on what kind of binder is used, concrete can be named in different ways. For instance, if a concrete is made with non-hydraulic cement, it is called a non-hydraulic cement concrete. If a concrete made of hydraulic cement, it is called hydraulic cement concrete. If a concrete is made of asphalt, it is called asphalt concrete. If a concrete is made of polymer, it is called polymer concrete. Both non-hydraulic and hydraulic cement need water to mix in and react. They differ here in the ability to gain strength in water. Non-hydraulic cement cannot gain strength in water, while hydraulic cement does. Non-hydraulic cement concrete are the oldest used in human history. Historical evidence also point out that the Romans used pozzolana, animal fats, milk and blood as admixture for building concrete.